Thank you so much, BetaNYC and City of New York, for hosting us. We are the MTA Open Data Team. My name is Lisa. I'm the Open Data Manager for the MTA, and this session will be led by Niki and Rahnuma, who are our open data scientists. We're also joined by one of our interns, Stefan, who will be helping debug questions in the chat throughout the session. So this session will cover how to use the Socrata query language to interact with one of MTA's largest open data sets, the subway hourly ridership data set. Stefan is going to put a link in the chat to our GitHub repository, which we'll be using in the later half of this session. So if you'd like to follow along, I recommend skimming the README now and making sure that you have the software installed. I will just note that the session will move pretty quickly because there's a lot to cover. So if you do get stuck, just remember the session is being recorded. And the GitHub will remain available online, so you can always go back and work through the steps that we'll be going through together. So yeah, just keep an eye on the chat throughout this because we'll be dropping links about MTA's open data program and resources throughout this session. And Stefan and I will be there to answer any questions if you have any or get confused about a specific step that we do in terms of filtering the data. The things we'll be covering here, again, are for MTA's open data, which is on the state's open data portal, data.ny.gov. But Socrata is the same vendor that the City of New York uses as well. So anything you learn here can be applied to the larger data sets on the New York City portal. So without further ado, I'll pass it over to Niki and Rahnuma to teach us more about Socrata query language.
Hello, can you hear me okay? Cool. Let me start sharing my screen just to go over some housekeeping. This is the GitHub page. Stefan should have dropped the link in the chat. Just want to call it out because in the event that you want to follow along with the Socrata query language and API connection, this is going to be what you need to set up. It covers access to Jupyter Notebook, and then at the end, there's a section about signing up, making an account with New York State so that you're able to exceed the data limit, which is 1,000 rows for free users. Yeah, just last call to set that up. If you haven't, no worries, this will be recorded. So today I am going to walk through the open data set for subway hourly ridership. This is our most popular data set, and I will show you ways to access and then export the data. This is great for people who are non-technical and want to see what the data looks like, as well as people who are technical and just want to quickly access the data. I'll also show you how to access the API from here. For your convenience. And then after I go over my section, Rahnuma is going to walk through the Jupyter Notebook that we were displaying in the GitHub link. Just a quick shout out, we do have a blog post about this, which will be shared in the chat as well. If you haven't read it, don't read it now because I'm going to cover a lot of what is covered in it, but no need to take notes because the blog will really document everything. But we do have additional information that we're going to share today. Cool. So subway hourly ridership is our biggest, most popular data set. It, as self-explained, has subway ridership estimates on an hourly basis for every subway station starting from 2022. So when you go to the home page, you can gather a lot of interesting information about the data set. You'll see that it's updated as of today. This is updated daily, and there is a 6-day lag just to account for any data delay. So you can imagine what was updated today as being data from today minus 6 days. Also, you can get a quick preview of what the columns are, their description, data types, and you can see it is a massive data set. So throughout this presentation and demo, we're going to be emphasizing that we highly recommend filters just to make it manageable for you so nothing crashes. Lastly, on this page, we do have links to attachments. This is included in all of our data sets where like you can understand more information about a general understanding of the data, as well as some of our methodology for data collection. And then there's also a little bit more information about the fields that we're including. So we have a total of 4 ways to access the data. The first one, if you're looking for a really quick view of the data before you get to querying or downloading, you can click on the data lens tab. And then you can just see, I think these are maybe the most, or maybe a random list of results. And this is just a great way to see what the data looks like. And you'll also notice these 2 buttons, which are going to be key for just navigating this whole page and all the data sets. The action one shows you all the options for actually accessing the data. And then export is for exporting the data. So first, after this, we're going to start with the second way to access the data, which is using our query tool. In terms of the demo, I think it's going to start at the Jupyter Notebook. If all of us query this at the same time, it might go really slowly. So just know that if it's going slowly for you, it might just be a high traffic time. As Lisa mentioned, this is on the broader New York State portal. So in terms of the ways that you can manipulate the data, we highly recommend filters. So the example that I'm going to cover is one of our peak hour analysis analytics, where we're going to look at what the ridership was on New Year's Eve, the last day of 2023 for Times Square. So we're going to start with filtering the timestamp. So as you can see, you don't really need coding knowledge to do this. It's a pretty friendly interface. And then I'm gonna filter for borough is Manhattan. And as you can see, there's an or operator. So I'm using and, so all of them will be applied if only if all the conditions are met. And then I'm going to do station complex, and I'm going to say contains Times Square in the name. So sometimes the station complex names can be really long. So I like to use the contains operator, because as you can see, Times Square, it's just a ton of subway lines go through there. So although we filter the data, this is basically filtering the rows within the columns, but next we'll need to group and aggregate in order to only isolate the population that we care about, which is the timestamp, station complex, borough. And then we're going to look at the ridership calculation sum of rows. Yeah. So as you can see, these are like the categorical values or columns that were originally in the data set, and then our newly calculated column. From this, you can see that there's now 25 rows, which is well within the 1,000 record limit. If you want to API from this data set or just download it, you can just click export button, and then you can download it in whatever format you want. For the API endpoint, you can just copy the link here in whatever format you need. This is pretty filtered out. So in the event you want to use the Socratic query language and do most of your filtering there, feel free to just not have as many filters, but we still recommend filters because there's millions of rows. Maybe you can just filter for the timestamp. So just important to approach the filter by having a specific question in mind. Yeah. So the last thing I'll show for accessing the data is our visualization tool. That's another integrated tool. You can also obviously access this and other visualization tools, but I'll go to the integrated tool. I'm not going to sign in, and I hope that it works, but essentially the same thing as the last integrated tool that we looked at, but it has the ability to create a nice visual for you. So I hope this works. We're going to look at ridership in Manhattan. This one is a bit slower, so it doesn't work. Okay, just to spare you all from watching me wait for that. I think I created a visual here. So this is just what it looks like when you select a timeline chart. You can also create different customizations with the bar color and the labels and access titles. And this is also a great way to visually understand the peak hour analysis that we're looking at. Yeah, so I'll just quickly go back to the API or how to access the API endpoint, just in case people want to follow along. So from this main homepage, or if you were in any of the integrated tools and you click on export, click on the API here. As you can see, out of these 53 million rows, there's the default limit. But if you create your account, you'll be able to exceed that and be in a pool of other users that have an account, which could be even faster. But then you just copy this, and then you can use it in the rest of the tutorial. So I'll just quickly walk through the rest of the GitHub page before Rahnuma gets started on the demo. But we do have these two configuration files that are useful to have, which if you clone the repo, you may already know this, but you can click on the code button and then through terminal or whatever sort of way that you want to clone this on your device, you can copy this or just download it and then you can access it locally offline. Yeah, did I miss anything?
No, I think you did perfect. Amazing job.
Cool, thank you. And now Rahnuma will walk through the Jupyter notebook demo.
Yeah. So my name is Rahnuma. I'm a data scientist at MTA alongside Lisa and Nikki in the Open Data Team, as well as Stefan, our intern. Okay, so just wanted to talk about two things. One is the local config file. It's useful if you have a account, as Nikki said, like you have sort of caveat to like the limits and not sharing the whole, as we say. So this is basically that contains your local configuration settings that aren't meant for like public eyes. That's why you don't see my proxies or my API key in here. And then one other one that I wanted to mention was the data utils. This is considered as a utility belt for our project. It's a Python module packed with functions that's designed to just simplify the data handling tasks and also establishing a session with the New York State Open Data portal using the information we provide in the config file. So just wanted to say those things. And these are kind of like the fundamental elements in place that's gets us ready to start our analysis. So let's move forward and unpack the actual data analysis process. I will quickly just slide through the notebook. Can everyone see the notebook, first of all?
Yep.
Cool. Before we jump into our data analysis, I did wanted to take a moment to appreciate the tool that we'll be using, which is Socrata Query Language, or SoQL for short. SoQL is like a powerful language that's designed for querying datasets that's hosted on the Socrata-based platforms. Think of it like a SQL cousin. It's kind of like SQL, but not really. I will explain it more in details, but it's tailored specifically for open data. So with SoQL, you can filter, sort, and aggregate like large amounts of data, such as the subway hourly ridership, directly within our browser. So no heavy databases required, and it's flexible, user-friendly, also really powerful for data analysis. And data scientists like us looking into insights without any overhead of traditional database management. So let's dive in to our first example, which is the peak hour analysis. Although we sort of dived into this topic in our blog post mentioned by Niki, it also should be in our chat. Please mention if you don't find it, we can send it again. But yeah, let's skim. So I'm gonna just skim through the query that sort of makes sense and talk about each of the SoQL parameter like it's a precision tool in data sculpting. So first thing is the where parameter, or this indicates our primary filter for specifying the time frame that we're interested in. We're specifying the New Year's Eve day, and then we're also looking into the time square, similar to what Niki had done in her demo. So one thing I wanted to mention also is the dollar sign that you see above. This is sort of like a magic wand that involves a specific functionality we need. And also the and symbol you will see later on is like your glue, I would say, binding these parameters into a single and coherent command. So those two things I wanted to mention. And then next parameter is the order. So this is where we dictate the sequence of our data in ascending order specifically. So this tells us the chronological story of ridership as the new year rings in. Then we have our group parameter. This groups our data by station and timestamp and ensures our results are organized. And lastly is the select parameter. This is like mainly the real star, I would say, because this allows us to pick our data's leading role or leading actor, the station complex, the transit timestamp, as well as the sum of ridership as the total ridership in the nearest whole number for clarity. So this is where I wanted to also mention the round function. This basically ensures the total ridership presents like in a clean whole number format, removing any trailing of zeros, any decimals. But if you wanted, for example, to have like one place of decimal, you would just change the 0 into 1. If you want 2 places, change it to 2. Fairly simple. But we'll keep it to 0. And now, so this quick tour around our query parameters like sort of sheds lights on the streamlined process we imply thanks to SoQL. While we don't really dive deeper here, our blog has all the query details. Understanding these basics empowers us to handle open data with precision and ease. So now, your final query should look like this, where we see the and the dollar sign connecting all these single parameters into one. So if you were to copy and paste this in our little cell. By the way, this notebook is already shared in the GitHub, so you have already the answers if you're interested. But I would like just watch this before you go in there. But yeah, this is what the final output should look like. Oh, for reference, we are basically changing this into a pandas data frame, which I feel like a lot of you guys are also familiar with. And this is like a different way of using it where we read it into a CSV rather than a JSON. Just wanted to show a different one other than like what we already have in the blog post. So we see here like our total ridership for that this Times Square station. So you can see that if you want to catch the ball, the New Year's ball, then you should probably go around like early 3 or 4 a.m. Just kidding, don't go that early. Okay, next I wanted to talk about different sort of analysis here. So for our second analysis, we'll investigate how ridership trends can be influenced by time-specific events. So our starting point is always come up with a question. So for instance, how does ridership on the 4th of July compare between 2022 and 2023 at Vernon Boulevard Avenue Station? So it's like a well-formulated question that you should come up with before you try to go dive into the analysis. That way you will be able to know exact filters and functions that you need using the SoQL query. Okay, so this is sort of the new, this is the sort of the approach that you want to go. You want to find like identify the station name. You want to find the date range, which for us is 4th of July for 2022 and 2023, and then you want to aggregate the ridership. This is another parameter using SoQL. So the query parameter is a very powerful ally. It's quite similar with SQL. So if you're familiar with SQL, this could be probably even more simpler for you guys. But if not, it's okay, stay tuned, I'll explain. So basically, query, this parameter has different clauses similar to SQL, which are select, where, order by, group by, limit, and offset. For those, it's like unlike SQL, you don't have the from clause. Only because the data set is a URL, we already know where it comes from, so you don't need that. So secondly, I wanted to mention also the date trunk y function right here. This is a function that sharpens our temporal analysis by truncating the dates down to the year. So comparing annual trends becomes much easier. And now I would like us to like construct our query together. Remember to keep our initial question in mind. We'll build it clause by clause. So first we want to select, similar to our previous analysis, and then we'll use the clause data trunk y. And then our timestamp, transit timestamp, and we'll denote it as year. So we're extracting the year from the transit timestamp column. And then you also want to select our station. So that will be station complex. And then we want to select the ridership column, and we'll want to sum our ridership as total ridership. And don't forget to round, because it will show trailing zeros after the ridership. Great. So that's your select clause. Next, we want to specify where our data comes from. So just basically write where. So it's not geographically where, but it's in time. So here is where you want to like set your date ranges. And then also you want to specify exactly which station. So I am going to I already have this set. So it's not, you have to wait for us. I'm going to explain. Like, so here, our question, remember, we're checking out like specifically Vernon Boulevard, Jackson Avenue on the 7 line. And then we're selecting transit time stamp for 2022 of 4th of July. And then we're selecting between 2023 of 4th of July. Cool. Now, we're going to group by. Group by. So here, with group by, we're telling SoQL to consider each year and station as unique entities, summing up all the rides within those groups. I would say it's like taking a magnifying glass to our time frame, ensures we only count the ridership that pertains to our query. So we'll do that year and station complex. Now, finally, we'll use order by. Oh, didn't do that. So order by is like, I would say a cherry on top, lining our results in a chronological order. So it's just visually nice to see the output that way. So I'm going to do it year in ascending order. So once we put this together, let's see what our query looks like. So just if you copy and paste this here, don't forget the $sign. And if you run this, it's pretty quick. That's because I have the account. So I would definitely suggest creating a developer's account if you're interested. And you can see here, based on observation of the output, there's a significant increase in the total ridership from 2022 versus 2023. So we can sort of guess that it's like a year to year over year growth in ridership. Cool. Now, for our final example, we're gonna switch gears to examine how fare categories like full fare, senior, student metro cards vary in use. So understanding these patterns is key, especially for policy implications. So now how do we extract these layered information? So let's find out. We'll start with like a straightforward query here. This is same parameter as we used earlier. And instead of selecting a station, we're selecting fare class category. This shows you all the fare types that is available in our data set. But we won't stop here. So to truly understand the usage patterns, we also need to compare other categories, like making sure we have transit time step in there, because there's no reason why you have to select a larger month if you just want to see the fare class category. So I would just select one day. Here I just selected the same New Year's Day and grouping it by fare class category, and then also ordering the fare class category. So it shows the Metro card first and then the Omni. So if you execute this cell, voila, you see our different Metro cards that are available and the 3 different Omni cards. Cool. Now you get to really compare the usage by fare category and compare the ridership across those different categories for a specific time period. Okay. And here we also want to introduce the payment method, which tells us the type of card that you use to swipe. So same, let's build, this is the query that you see. We select fare class category, we select the payment method, and we select the ridership column. But same thing as the other two analysis, we're summing the ridership and we're also rounding the ridership. Then we select a time frame, and I'm just selecting the recent this year, literally a few days ago from March 1st to March 15th. And then we're doing the same thing, grouping by fare class category and then by payment method, same way for order as well. And then let's run our query. So this example, okay, cool. So here you see the different fare class category, the Metro cards, and then the Omni. Obviously the payment method should be the same as the fare class category in the beginning, and then our total ridership. So we can clearly see because there are so many like categories available for Metro cards, it's like not totally all summed up for one category. You have like a variety versus for Omni, you see full fare has the most amount of ridership than Omni Other and Omni Senior and Disability. So that's why this is probably useful if we were to advocate more for the Omni fare categories, such as targeting the fare student and unlimited passes. Then like we can encourage more people to transition from MetroCard to Omni. And yeah, I just wanted to say one last thing that as you see in SoQL is very much of a tool for turning vast, large data sets into actionable insights. So whether you're a data analyst, policymaker, or just curious, the power to uncover trends and inform decisions is at your fingertips. You can do these kind of queries and post your analysis up online, and that could be pretty useful. So I definitely encourage you guys to dive deep into SoQL as well as our open data sets and the open data product platform. Explore and always keep asking questions. So if you have thoughts or queries, I'm all yours after this session. Thank you for joining me on this data journey.
One really good question we got was about the proxies in our notebook. So I do want to take time to cover that briefly. So if you're on a corporate network, so if you're joining this call either from inside the MTA building or maybe a city agency building or just like you're at work, you likely will need proxies to access or hit the API. But if you are taking this call from home, you can just remove references to that in the data utils Python file, and you shouldn't need to use them. It's more of like a corporate network thing. So if you've never used proxies before in your workplace, I think this is a question for your IT department. It'll just differ depending on where you're working. Elevator and escalators. So if you do want more information about elevator escalator outages and just availability in general, I dropped a link to that data set in the chat. I'd be super interested to see someone combine that with our ridership data set. So if someone does that, please shoot us an email at opendata@mtahq.org and let us know what you find. Yeah, half of riders are on unlimited cards. Highlights rich. There's a lot of good information in this data set that is very interesting in terms of how people are paying, whether they're using Omni or MetroCard, if that differs by location, just like generally interesting fair class information. Our team, I don't know, we're all really busy and don't fully have time to explore all these things. So please use the data set and let us know what you find and if there's something that we should be looking more into. All right, Mark has a question. It's unclear how to pull the code into Pandas with queries on the open data documentation. Let's see, how does fair capping get reflected in the payment method field? That's a really good question, and I don't think I know the answer to that off the top of my head. It might be explained in the overview document, but if it's not, our team will definitely make a note to add something about that because that is really important. I believe what I know about this data set is if someone's fair cap, their swipe is still gonna, or their tap will still show up in the data set because they are a rider. This is measuring like riders, not the amount of fare the MTA is receiving. So yeah, that should be reflected in the data.
I was just asking, I'm not usually using Python to access the SoQL to do SoQL queries. And usually when I'm sending, for example, like just spaces to an API, it like is coming back with an error. So I'm wondering in the I don't know, the text URLs that you've defined in the scripts here, there are like lots of spaces and stuff like that. And I'm wondering if that is getting encoded by like some of the other scripts you have in this little package that you have, or if it will work if you just send it this raw, you'll get the same output in return. And like under what circumstances? Yeah.
I think if you copy and paste the URL exactly, you should be able to like even download the data directly onto. I'll just show you right now, real quick. So on the notebook, if you were to copy and paste this URL exactly, and if you paste it onto a browser, then you automatically download the aggregated data. Yeah, so you see that the aggregated data that we had 2022 versus 2023, second example, it just downloads a CSV file for you automatically. But I hope that answers your question.
Let's see, continuing down the list, how many people are hopping? I'm guessing this is hopping turnstiles. Great question. We have an open data set about fare evasion, one for subway, one for bus. I can put a link to that for you to explore. And I would highly recommend reading the dataset overview document on this because we really go into detail about the methodology behind how MTA calculates fare evasion if it's of interest. All right, Isaac asked a great question about if you can join tables using the Socratic query language. And Stefan answered, it looks like there are no keywords for join. Great response. I did not know the answer to that question, so thank you, Stefan, for answering. So yeah, you would have to hit both data set APIs and then join the tables locally in whatever tool you're using. How is MTA capturing the ridership that skips their fares? Again, check out, I linked in the, or responded to the earlier question, our subway fare evasion data set. You can read the data collection methodology and overview for that data set. There's a lot of information there about how it's calculated. And if you have not read MTA's Blue Ribbon report on fare evasion, that also has a lot of good information about fare evasion. So what are your thoughts on using SoQL data for machine learning? I used it in school by downloading the file when it took 12 million rows, took quite a while to do so. I'm not fully understanding the question, but I think, yeah, Socratic query language is more about like pre-querying the data for whatever analysis you need. So it's really helpful, I think, a tool to use when you have a specific question in mind and want to use the data to answer that question. If you're just wanting to get like a brief overview of like what is available in the data set, I think the tools Niki highlighted at the beginning are more helpful to kind of like just explore the data. And then once you have the project that you're working on or analysis you want to do, you can write the SoQL query to pull out exactly it is what you need. But you always do have the option if you have an account to pull all the data if you'd like. It's just going to take a really long time. And New York State IT server will, I guess, try to accommodate the request. Do you know if it's possible using open data to distinguish between 311 service requests submitted in an MTA station versus above and near a station? This is a great question. So 311 data is provided by the city of New York. So it's a data set that we do use at the MTA, but we are a state agency, so like we are quite separate, I think, from all of the city data sets. I don't know if in the 311 data set you can distinguish between whether it is actually in a station or near a station. If someone happens to the answer, please let me know, because that's a great question. Oh, it looks like we can join using Socrata SoQL, according to Ralph. So if that is possible, maybe we can add that next year to or make an update to our notebook. Big round of applause to our data scientists, Rahnuma and Nikki, for leading the session. Huge thank you to Stefan for helping answer all these questions in the chat. And we hope to see you at the School of Data or at a future MTA Open Data event. One last thing I'll drop in the chat is our Open Data email address. It's just opendata@mtahq.org. So if you make something cool with our data set, or if you have feedback about this session, please email us, let us know. We love to hear about projects people are doing using our data, and even better if the results of your project are made public.